In this part, we'll be talking about the characteristics of a free undamped mechanical oscillator, and we'll be taking the horizontal spring. So the nature of motion in this case is called the simple harmonic motion. As for the characteristics, we'll see we have the amplitude, we have the period, the frequency, and the angular frequency. So we'll start first with the amplitude. When I talk about amplitude, so this means the distance between the equilibrium position and the maximum reached during the motion. And when I say maximum, this means the distance from this point to this point. This is x in terms of t. So this is what we call amplitude. Here, A, this is the amplitude. And also we can take it from this part to this part, which is also the amplitude. So if you have this horizontal spring, and for example, we elongated by a certain distance, xm, then this xm, this is what you call the amplitude of the oscillation. And as we can see, during one cycle, so if I take one cycle, then we'll have 4 amplitudes. Since, for example, when I say one cycle, this means the object was here, and then I released. When I released, then the object will return, then this is A, and then it will go to the minus xm. This is another amplitude. So let's say one oscillation, but ترجع لمحلها ترجع لهيدا point. So when it's coming back, this is also an amplitude, and here also we have an amplitude. So we'll see that one cycle, during one cycle, will have 4 amplitude. Now this for the amplitude, we continue for the period is the time needed for one oscillation, or this what we can say for one cycle. So if I take, for example, this is one cycle here, this is one oscillation, then the time needed, this is what we call period. So I can find it from a position of equilibrium to another position of equilibrium, من maximum to maximum, from minimum to minimum. So مهم أنا يقطع عندي one cycle. يعني for example, if I took, for example, this point here, لحتى يكون معي عندي one cycle, then I will take it to this point, then this is what we call one cycle. So هيدي بنسميها the period. Now, the period is what? Is the time needed to make one oscillation, and this is what we can write in this form. So period equal T over small n. So T is the time in second, and n is the number of oscillation. For example, if I say, for example, we have 20 oscillation during 100 seconds, then I can find in this case the period, and I will say that the period is equal to T over n, which is equal to 100 over 20, and this will be equals to 5 seconds. This means the period is equal to 5 seconds. Now, for the frequency is the number of oscillation per second. So if I want to write as formula, the frequency equal the number of oscillation per second. And we already said that the period is the time needed during a certain for a certain number of oscillation. Then we notice that the frequency is the inverse of the period, so we can say the frequency equal 1 over t. T is in second, and the frequency is in hertz. Now, in the case of a mechanical oscillation, we will have also what you call the angular frequency. Now, the relation between the angular frequency and the frequency is given by omega, or what we can say W, is equal to 2 pi times the frequency. Now, we'll see that we can name it proper angular frequency, since it's proper for the oscillator, and it will depend on the characteristics of the spring and the mass. So we'll see this in the next video. So here 2 pi is in radian, and this is in hertz, so which is 1 per second. So we'll have that the angular frequency is in radian per second.